My name is Laurent Dami. I'm working at Geneva.pm, and we build all our application for running reports in Perl, and we do a lot of databases. So this is what we are going to talk about. Relational databases, not all the other databases that you imagine, and learn how the Perl DBI works, and then some advanced Perl DBI. These are the main topics. So, relational databases. The acronym is RDBMS. Just a reminder, I guess everybody of you has done that in your studies, but just to remind it. So in the relational model, we deal with tables. Tables is a collection of rows, and each row has a collection of columns. That's the basic idea. And we have a couple of basic operations on those. The filter operation, just to take a subset of the rows which are in the table. We have the projection operation, which is to just retrieve a subset of the columns that are in the table. And we have the join operation, which is take two tables, take what they have in common, and build a new table from that. This is what I'm going very fast because I'm assuming everybody knows that. But it's good to remember it because there are many other kinds of databases around, especially quite recently in the Perl world. There is a whole movement called the NoSQL movement, which are other ways to store data. And it's used by some very big names like Google or Yahoo. They realized that for their applications, they didn't need a relational database. They needed something different, faster, some other features. So if this is what you want, you have various possibilities in Perl. But for the rest of this talk, we are going to go back to relational databases. So what does a relational database give you? A lot of things. There is this relational model, which is beginning, that I just talked about. But the RDBMS does the indexing, find your data quickly, can handle many concurrent requests, do that in a distributed fashion, and so on and so on. Because we are interested in Perl, not too much in database. If you start a project, you have to choose one. To choose a database. Sometimes you have no choice, because if you work in a company, this is my case, I have no choice, the database is already there. If you have to choose, well, you have many commercial databases. If you're interested in the open source world, I wrote down the three big players in that area. You have a very small database called SQLite, which is just a file with some API to access it. So the advantage of SQLite is very lightweight. This is why it's, I think it's the most, the database you find most in the world, because you find it on a cellular form, you find it in Firefox, you find everybody puts a small SQLite database in some devices. And for Perl, it's also very convenient, especially for web applications. For web applications, you don't need the database to handle the concurrency, because the web server will. And then you have the MySQL, which is the big player in the open source world. And you have another one which is less known, which is called PostgreSQL. Less known, but which is more targeted to the professional world. PostgreSQL tries to be the competitor to Oracle, and has a lot of features for high availability, making sure that you never lose your data. And now, talking to a database, the standard language is called SQL. It's called standard. It's not that much standard. There is a small core which is standard. By the way, you cannot get the standard if you have to buy it. It's not open source standard. But many people know it. And then every vendor has added a lot of special features to this SQL language. So this is a problem because SQL is not the same everywhere. SQL has two parts which are called the DML, data manipulation language, and DDL, data definition language. We're going to see that in a minute. So there are various approaches to SQL. Some people, they really don't like it. They don't want to think of it, and they want some layer on top of SQL to think in. They want to think in terms of application language. In our case, Perl, and they don't want to know what is going on. And there are some other people who think SQL is very important. If you want to optimize your request, you have to be very precise. And those people, they tend to write all the SQL by themselves because they want to control everything that is happening. And there are lots of people in between, and we are going to see. When you do a Perl program, you can choose to ignore SQL, you can choose to do it everything by yourself, or you can choose something in between. Data definition language is the part of SQL where you define the objects you are going to work with. So the main objects are define a database, define an index, define a table, and so on. And there are some verbs on that. The verbs are to create, alter something, or drop it, which means delete it or rename it. Here's the standard example: create a table. Table define a number of columns and the types of those columns, and then the database knows what is this table. The other part of the SQL language is data manipulation language, where you ask the data, where you work with the data, so you can query something which is already there, or you can add new data, modify existing data, or delete data. These are the few examples that are here. Now, before we go, we are going to Perl. Before we get there, one word of advice about writing SQL. Best practice is never to directly put your values in the SQL statement. If I go back to the previous one, you see here I have values directly in my SQL statement. And this is not good practice. Why? Because the recommended way is to placeholder. Placeholder is usually a question mark at the places where some real value is going to be used. And then in a second step, you tell to the database which value fit into those placeholders. Why is that important? There are three reasons. The first reason is just for convenience, is that the client code no longer has to worry about what is a string, what is an integer, or what is any other kind of data type. So if you don't use placeholder, you have to use different syntax. An integer is just digits, a string has to be quoted, and so on. A date sometimes needs to have two pound marks around it. If you use placeholder, you don't have to worry about it. The second point is more important, is if you use placeholders, the database can cache your statement. So it can remember that it has already done exactly the same query, just the value is different. And in that case, it can optimize it. Remember the execution plan. The second time you do the same query, it will be faster. And the most important point is the third one. If you use placeholder, you avoid what is called the SQL injection problem, which is the fact that if you take some input from the user, so the user has a form, enters something in the form, and then at some point, that input has to go into your SQL statement. If you don't use placeholder, malevolent user could type some SQL statements that will destroy your database. And your application will just take that input, inject it, that's the example I put here, computer typed something like this. And if you are not careful, you ask your application to do that and you have lost your table. So placeholder prevents that problem. Now we are going to Perl, at last. So the architecture of a Perl program which talks to a relational database is like this. On the bottom you have the database. Then you have something which is called DBI, which is the layer which is portable to talk to every database that Perl knows about. That layer has many drivers for various kinds of databases. And you have your Perl program here. And in between, there's something I put some dash because it's optional. Some people never use that layer. Some people do want to use that layer. It's called the ORM layer, Object Relational Approach. It's something intermediate that sits between your application and the DBI level. And we are going to talk about that at the end of the presentation. Now, you know that motto from Perl. Everything in Perl, there is more than one way to do it. At the DBI layer, there's only one way to do it. Everybody uses that DBI layer by team rules. It's excellent, and nobody wants to try to use something else. And in between, it's a big mess. You have ORM packages that you find on CPAN. There are several dozens of ORMs. So many ways to do it. We'll get back to that later. Okay, so remember that architecture. You have DBI, and underneath you have DBT drivers. I sorted the DBT drivers that you find on CPAN in 4 big categories. So the first category is the real drivers for databases that you find on the market. So there is a driver for Oracle, there is a driver for DB2, there is a DB2, a driver for SQLite, there was before, and so on and so on. Then there are drivers that fake a relational database. So for example, DBT CBS, the storage is just a collection of CBS files, flat files, in comma-separated value format. But that driver makes you believe you are talking to a relational database. Same thing with Excel or Delta directory and so on. It's nice, can be convenient. Then you have some DVDs which do not talk to the database, they talk to a remote server that talks to the database. So it's a kind of proxy or relay. And here are some examples. The one I'm using at work is that one, GDBC. So that's my Perl program talks to a GDB Java program which talks to the database. So usually it's a bit less efficient, but it's very nice to connect some pieces of software that were not meant to talk to the database. So if you have no Perl driver for the database, you will be one of these ways. And then there are some fake DVDs for testing, or especially this one is very useful to simulate the database. Then you can write your tests. When you write the DBT mock, you write what the database is supposed to return, and then you can check if your program does the right thing with that data. So if you have to write a Perl program that talks to some database and you have no DBT driver, what do you do? Well, you could write a DBT driver, but this is very hard, and it's advised not to do that. In the documentation, they really tell you, please don't do it. Really don't do it. But if you really want to do it, you have some quite good documentation there. So, of course, it's that simple. So the way is well written. You can know how to do it. The other solution is what I just said, is proxy to some other driver. So if you have an ODBC driver for the database, or you have a GDBC driver for the database, you can proxy to that one. Or there is a very nice product which is called SQL Relay, which you can also remote application. Now, in the DBI Perl layer, we always deal with handlers. So there are 4 kinds of handlers. There is a handle for the whole package. There is a handle for the driver. Those two, we don't talk to them too frequently. Then the important one is the database handle. So when you connect to the database, you get the database handle, and from that you can start doing some queries to your data. And you have a statement handle, so each time you do a new request to the database, you get back a statement handle, and that statement handle, you interact with that statement handle to get all the rows of the data that you have requested. Now, talking to those handlers, it's a bit special in Perl because they are, at the same time, they look like objects. So you call some methods, and then here are some examples of methods. You call on this is to the DBI handle. Those two are to the statement handle. And at the same time, it's not an object, it's like a hash. And you work with the properties of that hash. So you can read the properties or you can write them. But actually, it's not a real hash, it's what's called a tied hash. So each time you read or each time you write one of those properties, there will be some Perl code which is executed. And actually, it's quite convenient to have. It's very clever the way it was thought, because there are some Perl idioms that are very nice to use for dealing with those properties. It's easier than if you had all some methods. But okay, just to remember, we have those two things. So here is how you connect to your database. Everything relies on a connection string which is vendor dependent. So for every DBT driver, you read the documentation, they will tell you how to connect to your Oracle or how to connect to your SQLite or whatever. There is no global rule for it. And when you connect, you can. This is the short form. This is the longer form where you give a username and a password, and you can specify a number of attributes to tune the behavior of that handle. And if your program is going to need several times, in your application you have several modules, and each one of them needs to connect to the database, you can use this code, and then the first one does the real connection, and all further calls which have exactly the same parameters, they will get back exactly the same connection. So you reuse the connection instead of creating a new one at each step. So the attributes of I was saying before, DB database handle is like a hash. So in that hash you find those attributes. I won't talk about all of them, but this one is important. Autocommit. Autocommit says if it's true, it says that every time you do a single request to the database, it's performed immediately. So you say to the database, I want to update that stuff or to delete that stuff. It will be performed immediately in the database. If autocommit is false, we are assuming you are in the middle of a transaction. That means that the database records that you want to do this and this and this and that. But at the end, you have to tell, I want to commit all those changes, and all the whole bunch of changes that you did is going to go to the database. There is another slide about transactions a bit later. Another important property is raise error. So if it's false, the application has to check every time you do a request. It has to check: did my result go okay? Is my result okay or not? And if it said if it is raise error true, said before, it's quite convenient to have those attributes like a hash. This is one reason why it is convenient, is you can use the local construct from Perl. In Perl, when you say some local before an assignment, it means that assignment here is only true for the current block. And when I exit that block, the change that I made here disappears. So we can do that for example, for setting automate or for setting raise error, just for the scope of one block. When we go out of that block, it goes back to the state it was before. Here is a little trick. If you are in the Perl debugger, you have a database handler, you go to see what is inside, you see nothing. Absolutely, it looks like an empty hash file. Trick, if you really want to pick inside the database handle, is to say we know that the database handle is a tilde hash. So you have to ask Perl what is behind this tilde hash. This is the syntax for it. And if you do that in the Perl debugger, you will see all the details that Perl knows about your database handle. Okay, so time to now to get some data. Retrieve data, we ask our database handler to prepare some SQL, and what we get back in return is a statement handle. And then we can execute that statement handle by passing some bind values. Remember what I said before with the placeholders? So when I prepare this SQL, the SQL usually has a collection of placeholders in it, question marks. And then when I execute, I give a list of values, and each value is going to fill one question. And once this is done, I can ask my statement, please fetch the next row, and I do that in a loop. For each occurrence of the loop, I get an array reference, which corresponds to the database row. If I want to know what are the names of these columns in this array, I can do it like this. I can ask the statement handle what is the property name, and name is an array reference to the list of names of columns in that request. Yes?
One advice, please use name underscore LC or name underscore UC.
Right. Right there is. So as just said, there are three variants. Name is the short one. If you use name underscore LC, it says you want all those names in lowercase, and underscore UC, it says I want all those names in uppercase. And then you are sure that your application program always gets the same column names, whatever the database driver decides to. Because here, as I wrote it here, database driver decides if the column names are going to be uppercase, lowercase, or mixed case, or whatever. Okay, so that's for fetching rows. Just a small note that there is something called prepare cached. So the same idea as I said before with the connect cached. If I say prepare cached, it means that DBI is going to keep a list of all the SQL statements that I issued, and if the same statement comes several times, it's going to reuse one from the cache. Now, there is a whole list of different methods in DBI to get the data. So the first one that we just saw before was fetch. And there are some variants: fetch row array, fetch row array ref, fetch row hash ref, and so on. It's always the same idea. Get the data, and DBI can do some work to package that data as an array or as a hash or as whatever. And it can also, if you don't want to do a loop in your application, you can say, I want in one method code, I want to select all the rows from my scheme. The DBI layer will do the work, getting over. There is also a method for doing a vertical slice. So if I want a specific column from all my rows. Now, this is the basics, the real basics about DBI. Now we're going to see some more advanced stuff. So first thing is about transactions. So transactions are important to keep your data consistent. The example which is always given is you want to talk to a bank and you want to transfer some money from one account to some other account. You have to make sure that in one step you are going to withdraw some money from the first account and to deposit on the second account. And if something breaks in between, it's as if the whole thing never occurred. So you don't have to withdraw the amount for the first account and then your application crashes and the bank is not balanced. The way to do that in Perl is to do a transaction, and a transaction is like this. It says begin work. Begin work is going to turn, remember that property called auto commit. So begin work is going to turn it off, which means everything you do after that to insert the integrals and so on is not executed immediately. And when you are done, you say commit. This tells the database to do the whole thing. And if everything was well, you are done. Now, if there is a problem, you will get an error. And this is why we put the whole thing in eval block. So that if there is an exception which is raised by the database driver, we will know it at the Perl level by asking the sign. So this is the Perl variable for the last error. And so if this is true, we had an error. All things here never happen in the database, but we have to deal with the error. So what we do, first we remember what is the error message, and we try to do a rollback. We try to explicitly tell the database, please forget everything about what I asked before. But the rollback itself can fail. So we also have to evaluate that one and remember the result. And then we bring a message to the user saying that something was wrong with the. So this is the way you program it if you want to do it yourself. Now, of course, there are some ways to encapsulate that. You don't want to program all of this by hand every time you need to do the transaction. So there are those two modules on CPAN that encapsulate just the transaction aspect, DBI's transaction or DBI's connector, or you choose to work with an ORM. So again, we're going to talk about that at the end of the presentation. Usually an ORM also has some method for doing transactions. This example was just one level deep. You can, of course, has some nested transactions. So in the middle of the first transaction, we decide to want to open other transaction, this nested transaction. And some databases have support for nested transaction because they can remember, you can say, I want to save my state at some point. And if my nested transaction fails, I go back to that save point. I do not roll back the whole thing. I just roll back part of it. Not every database supports that, and not every ORM supports that.
Two small things. Not all databases support transactions at all.
That's right.
DVD CSV does not support transactions. And it is undefined what happens if you are inside a transaction and your whole application crashes or disconnects.
There is a slide about losing connections.
But even database releases might redefine their behavior for a disconnect inside a transaction. Okay.
Thank you. Okay, now another topic. The topic is about efficiency. If you use the normal calls that we saw before, every time you get a new data row from the database, Perl has to do some work. It has to allocate memory for storing those values, and then get the database values, put them in that memory area, and then when you are done with that row, just to destroy it. So if you work with millions of rows, it can be costly to your application. But there is a way to avoid that cost, which is you pre-allocate the storage. So here I say I create 3 Perl variables. Then I tell to my statement that every time I get a new row, I want to combine the results from that row into the memory that I already allocated before. This is the way to say that. And then your loop here is going to be much faster. But there is a cost, of course, is that each occurrence of the loop is using the same memory location. So you have to be aware of that, because you cannot, at the next time you execute the loop, you will lose values that were there just before. Now, we can ask the TBI for some information about the database we are looking to. This is metadata. So you can ask your driver what are the available sources, what database known. When you have a database, you can ask what are the tables in that database, and so on. You have other method calls to ask what are the columns in there. Sometimes you can even ask what are the relationships between rows, so foreign keys and so on. But this is not very portable. This was designed in the DBI data, but the implementation in database driver is not always complete. I would rather say that most of the time it's incomplete. So you are not guaranteed to always get a good answer to all these calls. But if you are lucky, that's a good way to ask some information about the database. This kind of stuff is really used by tools that, for example, do what is called code, create, retrieve, update, delete. You have some generic frameworks that build a kind of application skeleton, and they just connect to the database and try to guess what are the tables, what are the columns, and then they deal with everything. Of course, they need that kind of information, so that stuff. Now, when you have a database connection, it can break for a lot of different reasons. So one, I forgot to put it on that slide, but there is a method called tbh ping. So you can ask the database, are you still there? And of course, your application can do that repeatedly, just to be sure that there's somebody on the other end of the line. Now you have some packages that try to recognize that we lost the connection and try to help you to deal with that. Maybe to reopen the connection automatically. So you have those two packages in CPAN, retry or misconnect. Another one which is more recent, which is called DBIX connector. And again, this feature is kind of standard in several ORMs. And also some drivers have it. So this is the case of MySQL. You can ask the driver to reconnect automatically when it needs to. A word about data types. In databases, we have data types, like integer, strings, and so on. Blob, which is a binary large object, it's a big array of bytes where you can store an image or store a video or whatever. And you have sometimes in the database you have structured types. I mentioned here an array, but you also have some databases which have structured types, a bit like a hash, let's say. Now this maps to this has to map to some Perl data types. So almost everything in Perl is always a Perl scalar. So an integer, a string, or a blob, Perl will treat that as a Perl scalar. The null is a special value, so it corresponds to the Perl def. And if you have structured data types, at least in, I don't know the whole story, but at least in Postgres, if you have an array data type in a column, you get an array ref from the driver. Now, for large objects, I said it's a Perl scalar, but if your large object is a video of 30 minutes, it's going to be quite large for a Perl scalar. It eats a lot of memory. So that we don't want to do that. And there are some ways to talk with those very big columns in a kind of string manner. So you want to treat it like a string, which means you open a connection to that very large object and you read it by chunks or you write it by chunks. Again, this differs a lot between databases. So, here are some examples of calls you will find in the Postgres driver, other calls you will find in the Oracle driver. You really have to read the database documentation to do that. There's no portable Perl way to read for every database. Some information about tracing and profiling. There are a lot of very clever mechanisms within DBI. I don't know if many people use those, because you have to invest a little bit to really learn how it works. But if you need to go into your application and find out where you spent too much time and or where your codes go, you have those features. So you can set some tracing and you can choose it for profiling. I really don't go into details, but there's a lot of things there. So.
Question.
Yes?
Where does profiling information go to? Send it out?
I don't remember. I think you asked it, if I remember well, does anybody know the answer? No. I'm sorry.
Actually, thanks.
So this shows that I never used it. I know it's there. So if I need it. Okay. So just to mention that in some database we can have stored procedures. So some code which is in the database, not in the application. There's even one database which can have stored procedures in Perl. So Postgres, if you choose Postgres database, you can write Perl code that sits in your database server. It's probably quite nice. I haven't tried yet, but I really would like to try it. So anyway, if we have stored procedure, we need to talk to those procedures. So there are some special calls to say, I want to pass parameters to my stored procedure, or I want to get back some values from my stored procedure. At the time, okay. So we go to the last section, which is this section about object relational mappers. The whole principle is to say, in the database I have some tables and some columns. In my application I have classes and objects and methods, and I want to try to find some mapping between those two. And the idea seems quite nice and quite simple when you look at it, just like this. So we have one table, table 1. So for that table we create class 1. Every time I have a row here, I have an object here, and the attributes of my objects are just the columns of my database. So it looks simple. But some people ask, what does it bring me? Why should I use ORM label? This is an example of a question that was asked on the list. Here are some answers that what an ORM can do for you. It can create the SQL for you, especially when there's some repetitive things like doing all the joins. The ORM can do that. It can convert the data to Perl objects. It can encapsulate the transactions, it can recover the connection, it can compute the fields, and so on. So there are many features that can be useful. But it's not so easy to have this matching between tables and objects. Why? Because in the SQL, we can have a projection, so we just take two columns instead of all columns from the table. So what happens in my object? If my object is missing some information, the ORM has to deal with that. Other problem, if I want to do a join, I'm merging data from several tables. So what kind of object do I get if I merge data? Again, it's not obvious to answer that. And finally, there is also the example of functions that modify data on the file on the database side. The Perl layer is have difficulty. So this is just to say it's not without reason that there are so many ORMs in Perl, because there are lots of issues, and some ORMs try to focus on one thing, some other on other thing. The one which is most used in the Perl world right now is TBIX class. So there are some talks about it right here in the EMC, and there are lots of people working on that one, which are here too. I'm going to say a few words about the one I wrote, which is a TBIX data model, and lots of others. So just so we will imagine a model like this. This is how it looks when we use TBIX class. So you create a package for schema, you create some classes for your tables, and you say how they relate together, and then you have methods to inject data into that or to search data in those classes. I'm sorry, it's very fast, but go to the other talks to remember all of this. And here is an example from DBIX data model. We define in one file, we define all the schema and all the tables and the association between them. If you want more details on that, I will talk about it tomorrow. And here is a short example how to retrieve data from those things, including doing several joins and stuff like that. And okay, so we are done. Just put some pictures here on where you might find some more information. So principles of databases you can learn in textbooks. The DBI manual is very good but very long. It's an in-depth. You don't get DBI for free. You have to learn it. It takes some time. There is a good book about it. And so that's it. Good questions. Yes.
An idea for it's an idea for the talk. My idea is my version of Python.
Instead of yeah, it would be more regular. Yeah, thank you. Yeah. Okay. Okay, thank you.